Hello students, welcome back to Turito's live classes. How are you all doing? So students, we have started with this chapter called as Is Matter Around Us Pure? We have been at we have seen so many concepts, okay, and this chapter looks very important from chemistry point of view, okay. In this chapter we are learning core concepts of chemistry, okay. So it's time to revise whatever the concepts which we have covered during the last session. Okay, just grab your notebook and let's get started. So in last session we have seen the different types of solution, right? Such as saturated solution, unsaturated solution and supersaturated solution. So let's quickly revise about these three types of solution. Talking about saturated solution, I have given you an example, like if a class, we are having a class of 30 students, right, and there are 30 benches. So definitely tell me how many number of students can get accommodated in that class. 30 students, right? I asked you, what if I am having 10 more students to if you want to allow them to sit, will it be possible? No. So what did we say? We said that it is a saturated class with 30 students because that class has the capacity to accommodate how many students? 30 students only, correct? So we couldn't able to make them sit, like 10 extra students couldn't sit in the classroom, right? Again I gave you example. Suppose your class is set for 3 hours, okay, but your teacher is going to stretch it little bit, like 3 hours 30 minutes. Definitely you are going to get saturated, okay. Maybe you are not able to understand the concepts well, correct, because your maximum capacity to understand or to study the concept was for 3 hours, okay. So likewise we have seen the same situation or phenomena in what? Chemistry for saturated solution. Okay, we talked about one example where we took 100 ml of water. Okay, so 100 ml of water has the capacity to dissolve 36 gram of NaCl, correct, 36 gram of NaCl. Now when you try to dissolve 37 or 1 gram extra, okay, so actually water which is nothing but a solvent, right, it is a solvent, it did not allow the dissolution of 1 gram of sodium chloride because each solvent has its own capacity to dissolve the certain amount of certain quantity of certain solute. Here sodium chloride, which is our solute, right, which is in lesser quantity, okay, and solvent, this is in bigger or measure quantity. So 100 ml of water has the capacity to dissolve 36 gram of sodium chloride, right, and when we added 1 gram of sodium chloride, it did not get dissolved. This is what is the dissolved particle, okay, this is what is a salt solution, and this 1 gram of sodium chloride, it didn't get what? Dissolve. So what did we see? We saw that this extra amount of solute, I will write it here, 1 gram of solute is getting settled down at the bottom of the container, okay. Here we have dissolved how much? 36 gram of NaCl in 100 ml of water. This is what? Dissolved solution of dissolved solute and solvent, of course. Here we have undissolved 1 gram of sodium chloride, and this scenario, this situation, this solution is labeled as what? Saturated solution. You cannot add extra amount of solute in particular solvent beyond its capacity, beyond its maximum capacity. So tell me, how much capacity 100 ml of H2O or solvent has to dissolve solute? 36 gram of NaCl. Got it? Is there any confusion? Are you all able to recall? This is what we have covered in the last class. Alright. So talking about the next solution. So here unsaturated solution. This is saturated, definitely it is in opposite of saturated, something which is non-saturated. That then what does it mean? It means that if you have taken 100 ml of what? Water, 100 ml of water, and you are adding let's suppose 2 gram of NaCl. This is what is your solute. We are going to stick with the same example, okay, for our better understanding. 100 ml of water, and we have added 2 gram of NaCl. Correct? We have added 2 gram of NaCl. Now students, tell me, we just now observe that water, 100 ml water has capacity to dissolve 36 gram of salt. That means we can add more 34 gram of sodium chloride, okay. But when we add 2 gram of NaCl, we saw that you can add, add 34 gram of solute. That means this solution looks like what? Unsaturated. It has not reached up to its maximum capacity to dissolve the solute, right? And that is what we are saying, it's a unsaturated solution. It has the capacity to dissolve that solute, okay. Moving ahead, we have third type of solution, which is what? Supersaturated solution. Supersaturated, something extra than saturated. Then what do you mean by saturated? Just now we have seen, we have taken 100 ml of water, into this we have added 36 gram of NaCl. Now this is what? Your saturated solution, right? 100 ml of water with 36 gram of NaCl. This is what is, I am going to write here, saturated solution. Saturated solution. But we are not happy with this. We want 1 gram of NaCl to get added in this saturated solution. Remember I told you one that example, if a class is having 30 students, okay, and that is what is the maximum capacity of our classroom. But there were 10 students, okay, who were waiting to get their seats. But of course, our class is what? Saturated. So what did we do? Didn't I tell you, what if I call principal in the classroom? The moment he or she enters in the classroom, we observe that these 3 students are going to, they are going to create some space for the 10 students which are, standing out, because all of them want to study, right? So now as soon as we call principal, now there are some spaces, so that 10 students are now sitting in the class, and altogether 40 students are studying in the class, okay. So what did we do here? If I want to 1 gram of NaCl to get dissolved, we are going to heat the solution, remember. And what is happening? These particles which are dissolved, or they are in this saturated condition, they are going to create some spaces, okay. And that's why if they are going to create, let's suppose I am drawing it like this, okay, they are going to, why they are going to create spaces? Because of the heat which we are going to supply to saturated solution. As we are increasing heat, as we are supplying the heat, kinetic energy of these molecules is getting increased, right? Kinetic energy of these molecules getting increased. Because of this, these molecules are starting moving from here to there, and this is giving, or this is resulting in some spaces. Now when you are going to add this 1 gram of NaCl, so definitely it is going to get accommodated in these spaces. Why did this happen? It happened because of the supply of heat, okay. And now we observe, okay, now this 1 gram of NaCl is dissolved, it is dissolved. So actually we are having now 37 gram of NaCl in 100 ml of water. Followed? So this solution is what? This solution is called as super saturated solution. This is what? Super saturated solution. Got it? Now my question to you is that, what if we are going to supply this heat? What will be happening here? Tell me, apply the logic and tell me. what will be the condition here if we are going to remove the supply of heat? See, you are removing or you are cutting off that extra flame or the extra amount of heat. Because of that, actually system is going to cool down, which means kinetic energy of energy is getting decreased, and that's why these molecules are they are going to come towards each other, and the dissolved particle are going to get what? Crystallized. Initially they were dissolved, now they are getting crystallized, and they are like the system is going to throw them out. That means not literally, but there will be separation of these dissolved particles. Okay, when it's happening, when we are going to cool the system or cool the supersaturated solution. Got it? Is there any doubt? Is there any confusion? Crystals are going to form when we are going to cool down the supersaturated solution. The extra, that means here 1 gram of NaCl, when we heat up the saturated solution, they got dissolved, the particles got dissolved. As soon as you are going to cool down the supersaturated solution, crystals are going to get formed. Okay, I mean extra amount of solute is going to get separate out in the form of crystals. Got it? Is there any doubt? Is there any confusion, students? So that was all about the last session. So what are we going to learn in today's class? Let me tell you the learning objectives. In this session, we are going to talk about the new concept called as what? Solubility. Solubility. Just now we have seen that extra amount of solute is getting soluble, or it's getting dissolved in what? Saturated solution. Okay, so this is what is nothing but a solubility. We are going to see what is the exact definition or how are we supposed to define solubility. Okay, apart from that, there is next concept which is nothing but there are some factors which are going to affect the solubility. We know that a solution get formed how? When a solute is getting added in the solvent. Okay, when solute is getting added, it is getting dissolved in solvent to give you what? Solution. That's why we say, that's where we say we are having solution. It can be solid liquid solution, it can be liquid liquid solution, it can be gas liquid solution, liquid solid solution. We have seen how many combinations? Quickly revise it. 9 combination, right? So we have studied about 9 combination of what? Binary phases, I mean binary solution. Binary is nothing but 2 components are getting involved. It can be liquid, 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 solid, liquid, gas, anything. Correct? So that is how we get the formation of solution. Now we have something to do with solubility here. Okay, and what that we are going to cover it soon. So here solubility is playing the major role to form a solution. Okay, to form a solution. And there are certain factors which are going to affect the solubility. Okay, factors such as what? Temperature and pressure. Okay, these 2 factors are going to decide the solubility. Okay. So students, yes, these are few concepts which we are going to talk in today's session. Okay, I hope you all have got an idea how our session is going to look like. Okay, shall we get started? All right, let's move. Students, here I can see a solute, right? This is what is solute, which is in what? I'll write minor in quantity or lesser in quantity, right? And we are having a solvent, right? So, this is what is a solution, this is what is solvent, which is measure in quantity, correct? When both of them are getting dissolved with each other, we are going to get a solution. Okay, so try to understand what do you mean by solubility is. So, the maximum amount of solute in grams, which can be dissolved. Okay, the maximum amount of solute, this is what is a solute. So maximum amount of solute which can get dissolved in solvent. Solvent, see students, it has to be in 100 grams. Okay, if we are talking about solvent, it has to be in 100 grams. So we are talking about in terms of unit such as grams. Okay. So we need to find out that if I am having a solvent which I have taken in 100 gram. Okay. So in my 100 gram solvent, how much gram solute can get dissolved at a given temperature? At a given temperature, at a certain temperature. Okay. So the maximum amount of solute in grams which can be dissolved in 100 grams of solvent at a given temperature to form a saturated solution. This is what is important. Okay, try to understand why I am highlighting these words, because these are some important words. Okay, saturated solution is called the solubility of the solute in that solvent at that particular temperature. You must be finding it's very long or lengthy. Try to understand. I am going to stick with this example which we have seen. 100 gram of what? Water we have taken, correct? So I am going to write it. Suppose this is what is water which we have taken. This is 100 gram water. I told you that 100 gram of water has its maximum capacity is what? How much? It can have 36 gram of NaCl. It can dissolve. Okay, so the maximum amount of solute in grams which can be dissolved in 100 grams of the solvent. So 100 gram of water can dissolve 36 gram of NaCl. Focus on the unit also. So we have taken 100 gram of water. In this water, 36 gram of NaCl can get dissolved by the solvent at the particular temperature. Is known as what? Solubility. It is known as what? Solubility. Okay, I repeat, the maximum amount of solute in grams which can be dissolved in 100 grams of the solvent at a given temperature to form a saturated solution. And we know that, what do you mean by saturated solution? It is that type of solution where we see the maximum limit or maximum capacity of any solvent to get dissolved certain amount of solute. Okay, so on the basis of this, I can say different solvents are having their own capacity to dissolve different solutes. Okay, all right. So to form a saturated solution is called the solubility of the solute. So this is what is the solubility of sodium chloride. This is what is the solubility of sodium chloride. How much is this? 36 gram in 100 gram of H2O. So try to understand different solutes are having their different solubility in different solvent. So whenever we talk about solubility of solute, you should mention in which solvent. Okay, here 36 gram of salt in water, which is understood how much water? 100 gram of water. That is what? A solubility of sodium chloride. Got it? Why am I saying so? Students, it's not needed, this is a salt, right, which is 36 gram. Now you must be saying, ma'am, sugar also can get dissolved in water. Yes, it can. Then you may be think, ma'am, it must be 36 gram of sugar. No, it's not needed. That's what I'm saying. Different solutes are having their own capacity. Okay, so likewise different even solvents are having their own capacity. It's not needed like all the solvents and solute are going to, they are going to dissolve in same manner or the value is going to remain the same. No, it varies solute to solute. It varies solvent to solvent. Following? Is there any confusion? Is there any doubt? For an instance, if I am taking example of what? Potassium nitrate. Okay, it is like solubility of potassium nitrate in water is what? 32 gram. 32 gram of potassium nitrate. So that in the same solvent. Okay, these are two different solute, but their solubility is different. Got it? Okay. Concentration of solute in saturated solution is the same as the solubility as the solute at that temperature. Okay, so how much or how many solute particles can get dissolved in 100 gram of solvent is what concentration of the solute. Okay. So, a concentration of solute in saturated solution is the same as the solubility of the solute at that temperature. So, concentration is nothing but maximum amount of solute gets dissolved in that solvent at the given temperature. Okay, its concentration and solubility of that solute in that given solvent remains the same. It remains it is equal. Okay. The solubility of solute is expressed in grams per 100 grams of the solvent. It is very important. Okay, mark it as very important. Whenever we discuss, whenever we define solubility, try to understand it is going to get expressed in gram per 100 gram of that particular solvent, and solvent can be any substance. It's not needed we are just focusing on water, then it means only solvent which we take is water. No, we have seen we are having other solvents. It can be ether, benzene, right? So these alcohol, these are different types of organic solvents also can be get used to form a solution. So all I want you is that certain gram of solute is getting dissolved in 100 gram of any specific solvent is what is the solubility. Okay, is nothing but solubility. Of course, we have to focus on the word at a given temperature. All right, let's move ahead. Maximum of 36 grams of common salt, which is nothing but sodium chloride, can be dissolved in 100 grams of water at 293 Kelvin. So yes, that is what we have discussed. So tell me, what is the solubility of sodium chloride? What is the maximum capacity of that solute to get dissolved in 100 gram of what? Water. At what is the temperature? 293 Kelvin. Student, we know that temperature is nothing but it's a degree of hotness or coldness of that particular matter or body or substance. Correct? And we know that it has two Kelvin and degree Celsius, even Fahrenheit. These are somewhat scale or units which we use. Correct? Now we need to understand if 293 Kelvin, can anyone tell me what is the temperature in degree Celsius and how do we calculate that? Quickly, we have seen this conversion from one unit to other. What do we do? 293 minus what? 273 gives you what? 20 degrees Celsius. Correct. So they are saying that maximum of 36 grams of common salt can be dissolved in 100 grams of water at 20 degrees Celsius, room temperature, right? So try to understand, this is what is the solubility of sodium chloride at room temperature at a given temperature. Got it? All right. Therefore, the solubility of common salt in water is at 293 Kelvin is what? 36 grams. Okay. Is there any doubt? Is there any confusion, student? If you want to make a note of this, please you can quickly write down this definition. Okay. And for example sake, you can note down this example of salt, like solubility of salt in water, 100 gram of water. Okay. Let's try to understand the second point, which is nothing but effect of temperature and pressure on solubility. What happens if I am going to increase the temperature? What will be that effect which we observe on solubility, whether it increases or it decreases? What if I am going to increase the pressure or decrease the pressure, and like how solubility increases or decreases? That's what we are going to understand. So we are having solubility of solid in liquids, solids in liquids. So liquids here, liquid is nothing but a solvent, okay, and solid is what? Your solute. So we are having liquid type of solutions. We have seen, we have learned this combination, right? So moving ahead, when a saturated solution at a particular temperature, that means what, room temperature, is heated, it becomes unsaturated. Try to understand. I am going to draw it, a saturated solution. Okay, saturated as what? This is what your 100 gram of water. Okay, saturated, that means it has 36 gram of what? Salt in it. Correct? It is saturated. It has occupied, or it has reached towards, like solvent has reached towards its maximum capacity to dissolve what? Solute. Got it? This is what? Saturated. So when a saturated solution at a particular temperature, suppose it's happening at room temperature, is heated, if I am going to supply heat to this system, okay, to this solution, it becomes unsaturated. It becomes unsaturated. Students, this is what something which we have learned. These are some molecules of the solution. Okay, these are some particles which are there inside the solution. Now when you are going to supply the heat, what happens? Come on, quickly, like tell me what happens. We have seen just now, whenever these particles are going to get absorbed the heat energy which we are supplying, this is what is nothing but external heat supply, right? This is the flame. Okay, it is going to give heat to these molecules, and what happens? Kinetic energy. Yes, this is what I want, like this answer I wanted from you all. Kinetic energy of this system, kinetic energy of these molecules are going to get increased. They are getting extra charged, extra activated, and because of that they are going to move away from each other. Again, there is creation of spaces. Okay, what is going to form? There are, we observe, they are going to get away from each other, and that's why there are some vacant spaces. Okay, they are going to create some spaces among themselves. And to this solution, if I am going to add, let's suppose 1 gram of salt. Okay, if I want to dissolve this salt, now it has some space, right? That's what we can see. Now by heating, on heating, saturated solution is unsaturated. That's how when you are going to pour 1 gram of solute, it is going to get what? It is going to get soluble, because it has extra space which it wants. 1 gram of salt. Okay, so what you have done, you have increased the temperature of the system, and that's why solubility is increased. Earlier, when the solution was saturated, there were no spaces. Okay, so this solvent is not able to, it wasn't able to accept extra amount of solute. But now what we have done, we have supplied the heat, we have increased the temperature. Arrow in the upward direction says that something has increased. Here, increasing on temperature, what we have done, kinetic energy has been like increased. I'll write it here properly. Increase in temperature, kinetic energy is increased, and increase in kinetic energy, intermolecular spaces, I'll write here intermolecular spaces increased. Okay, and now when you are going to add extra salt, it is going to get soluble, and that's why we say solubility is getting increased. Solubility is getting increased. So what what is the conclusion out of that? Whenever we are provided with a saturated solution, as soon as you are going to increase the temperature, kinetic energy of these molecules is going to get increased, and intermolecular spaces are going to get increased, and that's why I can say the extra amount of salt get soluble, it gets dissolved, which means I can say solubility is going to get increased. How did this happen? Because we increase the temperature of the solution. Followed? Quickly make a note of this too. Alright, let's move ahead. This is because the solubility of a substance generally increases with increase in the temperature. Always try to understand. Increase in temperature going to increase the solubility of the solution, and hence more solute can be dissolved on increasing the temperature. That is what we have seen. So I can say temperature is directly proportional to solubility here. Temperature is directly proportional to, so as you are increasing the temperature, solubility is going to get increased. Is there any doubt? Is there any difficulty? Okay. Now, next we are having, if saturated solution at a particular temperature is cooled, then some of the dissolved solute will separate out in the form of crystals. That's what we have just covered, right? Now, when we have seen, we are provided with a saturated solution and we converted this saturated solution in what? Unsaturated, correct? So, these were some dissolved particles, okay, and now we have added some extra particles, okay. So, this is how what we have, I will write it here, supersaturated solution. In a way it is supersaturated solution only, okay. Now, earlier we supplied heat to the solution, right, and that is why the conversion had happened from saturated to supersaturated solution, and when we increase the temperature, solubility did increase. But what if we are going to cool down, we are going to cut off the heat supply, okay, I am writing here on cooling. On cooling, the kinetic energy of these molecules is getting decreased. They were initially away from each other, now they are going to come towards each other, okay. I am going to write it here again. On cooling, the dissolved or the particles which were there in the supersaturated solution are going to get away, they are going to come closer to each other, and that's why the extra amount of solute is going to get what? Separate out. It is going to get separate out because of the cooling. Okay, and that's what we have written. If saturated solution at a particular temperature is cooled, then some of the dissolved solute will separate out in the form of crystal. These are the extra added solute are going to get separated by the formation of crystal when we are going to cool the saturated solution. Okay, is that followed? Quickly make a note of this too, students. All right. This is because solubility of soluble decreases on cooling. That is what is the thing. If solubility of that solute is increasing as we are increasing the temperature, and I told you that temperature is directly proportional to solubility. Now, if we are going to decrease the temperature, definitely solubility is going to decrease, and extra like that solid is going to get what? Crystallize. Got it? Let us move ahead. Solubility in gases in liquids. Okay, we are having different combination here. Gases in liquids. Just a minute, earlier we have studied about solids in liquids, right? Yeah, this is what we studied, or we covered solids in liquids. Now try to understand. We are having next combination where gas is nothing but a solute and liquid is a solvent, correct? So we are going to understand how this solubility is getting affected. Okay, when we are going to increase the temperature, what is happening with gas solute. Okay, the solubility of gases in liquids increases on decreasing the temperature. So take a pause, read it again. The solubility of gases in liquids increases on decreasing the temperature. I would like to remind you something. Gas is a solute, liquid is a solvent. Okay. So what we have learned, solubility of gases in liquids increases on decreasing the temperature and decreases on increasing the temperature. It's very simple, try to understand. Let me write it here. Consider this is what is a gas in liquid. We are having these are liquid, okay, this is what solvent, and we have taken solute, right? So gas and liquid that kind of combination we have as a solution. Students, we are going to, if suppose we are going to increase the temperature, what is going to happen? Try to understand. While studying about the physical classification of matter, we have seen solid, liquid and gas. So among these three physical states of matter, tell me which is having intermolecular spaces highest, or which particle are very energetic, which particles are very energetic among these three. Yes, gaseous particles are very energetic, they are the most energetic particles among these three states of matter. They are already in the, like they are already extra charged, or they are having the most amount, like measure, I can say they are most energetic. When we are going to heat this solution, okay, definitely they are going to get what? Extra energy, okay, and now again they are going to move from here and there more, like rapidly, the movement is going to happen very rapidly, okay. And if we are going to supply this heat continuously, students, there will be a point that these gaseous substances, these gaseous particles are going to escape from this solution, okay, they are going to get escape. And that's how we say, as soon as you are increasing the temperature, basically what are you doing? You are decreasing the solubility. Now gaseous particles do not want to stay with liquid particles, because they have already gained lots of energy, and with this energy they are ready to move, they are going to they are going to fly away, basically they are going to escape themselves out. If it is happening, definitely I can say solubility is getting decreased. Solubility is getting what? Decrease when we are increasing temperature. Okay, when we are having solid in liquids, in that type of combination, when we are increasing temperature, solubility is increasing. But we are having gases in liquids. In this, when we are increasing temperature, solubility is getting decreasing. Solubility of gaseous solute is getting decreasing. Okay, it is getting decreased, right? So what shall we do? How about not supplying the heat? How about decreasing the temperature? Okay, so what is the case number 2 here? We are going to decrease the temperature. Arrow in the downward direction tells that something is decreased. Okay, so here we are going to decrease the temperature, because we just now we have covered that when we are going to increase the temperature, these gaseous molecules are getting extra charged. Okay, they are very energetic, they are already energetic. If I am not going to supply the heat, they are having enough energy to move here and there, okay, because of their structural arrangement, okay, which we have seen in the physical classification of matter, right? But if you are going to supply heat, if you are going to raise the temperature, of course the energy is going to get double, and because of that they are going to escape the solution. That's how I say solubility is getting decreased on increasing the temperature. What if I am going to decrease the temperature? Now will they able to escape from the solution, or is there any change in the solubility? Yes, since we didn't supply any heat to the solution, or we decrease the temperature of this solution, definitely they are going to what? They are not going to move away from each other, they are going to come closer, and that's how I can say they are going to closer to the liquid, which is a solvent, and it is going to give us the result where I can say solubility is getting increased. Solubility of gaseous solute is getting increased. Followed? So try to understand, the solubility of gases in liquids increases on decreasing the temperature. If you are going to decrease the temperature, kinetic energy is going to get reduced. The movement of these gaseous particles is going to get reduced, and they are going to come towards each other, and that's how the solubility is going to increase. Understood? Or decreases on increasing the temperature. Okay. Is there any doubt? Is there any problem, students? All right. Make a note of this. Quickly you can make a note of this. Okay. For example, water contains dissolved oxygen. Yes, see, water is nothing but a liquid which is a solvent. It has a dissolved oxygen which is a gas. Now, if you are going to increase the temperature, oxygen is going to released. The solubility is going to decrease. And when you are going to decrease the temperature, it is going to be soluble. when water is boiled, the solubility of oxygen in water decreases. You must have seen there are some water vapors are coming out when we are boiling the water. Along with that, even gaseous substance, oxygen is getting released because of increase in the temperature. But decreases, and the excess oxygen escapes in the form of bubbles. Okay, so the bubbles which we observe, this is nothing but what? Oxygen molecules are getting escaped. Okay, solubility is getting decreased on increasing the temperature. The solubility of gases in liquids, however, increases on increasing the pressure and decreases on the decreasing the pressure. Okay, so students, that was all about the temperature. If we are going to increase the temperature, what is going to happen, and if we are going to decrease the temperature, what's going to happen, like what are those effects which we observe on solubility of solute in a solvent. Is it okay? Is it all right, everyone? Is there any doubt? Is there any problem to you all, students? Okay. So now, after completion of one of the factors such as temperature, it's time to move ahead and try to understand the next factor such as what? Pressure. Okay. So what is going to happen if we are going to increase the pressure? See, we are having three physical states of matter: solid, liquid and what? Gaseous substances, right? If I am having solid in liquids type of solution, students, if we are going to compress the solid, do you think it's very easy to compress solid? If I am going to apply some pressure, will it is going to give you any result? That's what we have seen. Compressibility, it is like solids are almost like negligible. Like when it comes to compress, like we are not, it's hard to compress them basically. Among these three states, it's hard to compress. So solubility won't get affected in solid in liquids when we are going to apply some pressure. Okay, so we cannot compress these solids, correct? The solubility of gases in liquids, however, increases on increasing the pressure and decreases on the decreasing the pressure. So here we are having next combination, students, that is what? Gas in liquid. We have studied that solids are hard to compress. Okay, so there won't be any effect of increasing pressure in solid in liquids type of solution, correct? But what if I am having gas in liquids type of solution? So here we have written solubility of gases in liquids increases on increasing the pressure. Okay, so here I will write for this type of solution, pressure is directly proportional to what? Solubility. It's directly proportional to solubility in case of gas in liquid type of solution. Okay, is it are you able to understand it? So we are going to see it in detail. Do not worry about that. Okay. See, we have given one example during the manufacture of cold drinks. Okay, it is one of the examples from our daily life that we drink cold drink, right? So we have seen it has what? Carbon dioxide, which is dissolved, correct? So it is dissolved in water. So I can say that it's a gas in liquid, carbon dioxide in water. So this type of combination we can observe here. So how did we do that? We have increased the pressure. Okay, on increasing the pressure, this carbon dioxide is ready to dissolve in water, and that's how I can say increasing pressure, solubility of gas in liquid increases. Okay, so see, when a bottle of soft drink is open, the pressure inside decreases. So in that bottle, okay, this is what is a bottle. If we are having lid, right? So if we are going to open this lid, you must have observed that some gas is getting liberated out. Okay, so basically we have applied some pressure, and because of that this carbon dioxide is dissolved in water, okay, in that cold drink. As soon as you are going to open the lid, there is a liberation of carbon dioxide. That means when you are removing that lid, actually you are decreasing the pressure, and decreasing pressure leads to decrease in the solubility of carbon dioxide in water. Okay, so try to understand, it's directly proportional to pressure is directly proportional to solubility. All right. So yes, when a bottle of soft drink is open, the pressure inside decreases and the solubility of carbon dioxide also decreases. Okay. So the excess dissolved carbon dioxide escapes in the form of bubbles. Okay. So here also I can show you, see here we have this situation, okay. This is what is a piston. With the help of this we are going to apply the pressure in the system, okay. So earlier we are having these many different particles before applying certain pressure. This is what is liquid, I will just mention here, this is liquid and these are gaseous particles. Now when you are going to increase the pressure, you are going to apply the pressure, because of that the particles are getting dissolved in the liquid, okay, and that's where we say we are having a gas into liquid type of solution, okay. So on increasing, or when we are applying pressure, gaseous particles are getting like the solubility of these particles is getting increased, okay, and vice versa. If you are going to decrease it, solubility of these gaseous substances are going to decrease, okay. Is there any confusion, is there any doubt? We have seen with the help of a daily life example, okay, the phenomena is getting explained with the help of cold drinks or carbon dioxide which is present in cold drinks, right? Is there any doubt, is there any confusion, students? Yes or no? All right, so based on this we are having some questions. Quickly let's get done with this. Solubility is the amount of solute dissolved in what? Like I just want a proper amount of solvent. Quickly, it has to be 100 gram of solvent. Always remember the definition of solubility, okay. Which among the following is an example of solid solution? Okay, solid solution has solvent which has state solid, right? So copper dissolved in gold, ethanol in water, glucose in water, sodium chloride in water. So elimination method, water is liquid, right? We do not want these options. Gold is what? Solid, and this is what? Copper is solid. So solid, solid, this is giving you the combination for solid solution. That's why your option is correct. Next, the solubility of a substance in a solvent depends on temperature, pressure, nature of the solute and solvent. Temperature, yes. Pressure, yes. And how the solute is, like what kind of nature solute and solvent has, it is also one of the considerable factors which affect the solubility, okay. So that's why our correct answer is option D, all of the above. So yeah students, that was all about for the day. We have learned about the solubility and the factors affecting to solubility such as temperature and pressure, okay. So yes, that was all about for the day students. Till we meet next time, take care and keep studying.